There's a chance that our whole smooth-way universe is found within the so-called space void. This locale has moderately small matter compared to other corners of the known universe and is much less thick than somewhere else. In other words, we might exist in a discuss bubble in a cake. In the event that that's genuine, it would cruel. We're indeed lonelier than we thought. In our universe, all worlds are continually moving absent from each other. To get it, how distant they move, researchers utilize something called the Hubble consistent. It's like a speedometer, but for worlds. Be that as it may, there's an enormous puzzle called the Hubble pressure challenging our information, approximately the universe's extension. Researchers utilize to consider the Hubble steady, a solid, direct, but later perceptions address this unwavering quality. The speeds we see in genuine life do not coordinate up with the separations we calculated and anticipated. Analysts taking after the moves of supernovas watch that the universe appears to extend speedier around us than it does generally, as in case it's effectively maintaining a strategic distance from us. Considering this, researchers started to accept we might live in an enormous void. Enormous voids are endless purge spaces between universes, making our world seem like a huge wipe. Right after the enormous blast, the universe was a hot compressed plasma with minor varieties in thickness called quantum vacillations. As the universe extended, these changes developed, making locales of shifting matter thickness. The universe didn't extend consistently, driving to clumps of matter shaping enormous structures like worlds, orchestrated in colossal dividers and fibers, with colossal holes in between. These crevices are voids, too known as dull space. Voids aren't genuinely purge. They hold more than 15 of the normal matter, found all through the universe, counting gas, tidy, dim matter, and indeed, stars and systems. Be that as it may, their thickness is around 1/10 of the normal matter thickness. Voids, more often than not, have a breadth extending from approximately 30 to 300 million light a long time. In the event that you were within the center of one, it would see like unceasing haziness, with the closest stars nearly imperceptible. A few voids, called supervoids, are particularly expansive. The biggest known one, imaginatively named Mammoth Void, is 1.5 billion light-years, absent with a breadth of 1 to 1.3 billion light-years, containing 17 partitioned universe clusters inside its scope. However, the largest vacancy may well be the cold spot, and curiously huge and chilly zone of the universe, watched through microwaves. In 2015, scientists proposed that this could be a supervoid, conceivably the biggest ever, called the Extraordinary Void, with a vacancy of around 1.8 billion light-years in breadth. A few researchers argue over its presence, whereas others propose it may be a follow of a collision with a parallel world. As the universe extends, these voids will develop, and the walls connecting system clusters will extend and break, eventually clearing out gravitationally bound system clusters as islands within the extending vacancy. We could be a uncommon event in a supervoid with 15 of the matter, clarifying why we're encompassed by moderately few systems. This disclosure challenges the standard show of cosmology, proposing gravity carries on in an unexpected way than anticipated. Researchers call this the nearby gap, which might hold clues to explaining the Fermi catch 22. Maybe the chance of shrewdly life creating adjacent is exceptionally low, with aware creatures existing past our supervoid. Be that as it may, life within the universe may well be more common than already thought. In spite of our apparently separated position within the universe, our possessed sun-oriented framework offers interesting conceivable outcomes for life. Venus, in spite of the fact that harmful, might have facilitated life within the past when its conditions were more Earth-like. Damages, presently a cold desert, might have had streams and lakes with antiquated life, possibly clearing out fossils and surviving underground organisms. The moons of gas monsters like Jupiter and Saturn moreover display trust. Europa's subsurface ocean, Enceladus's water tufts, and Titan's hydrocarbon lakes indicate at situations where life seem possibly exist, though with diverse biochemistries from those on soil. Investigating these firmament bodies will take decades. Our gauges recommend the observable universe might have around 5.3 trillion habitable worlds. One promising candidate is Kepler, 186, a potential Earth-like planet fair, 10 bigger than soil, circling a ruddy overshadow star around 490 light-years absent. Indeed, in the event that we are in a supervoid, we're still fortunate to have many galaxies and planets around. In the event that we discover a way to travel through the universe, clearing out the nearby gap wouldn't be a problem. The look for life beyond soil expands past fair, trying to find tenable planets. It, too, includes understanding the unique environments that might bolster life in shapes we have, however, to envision. The extraordinary conditions on planets and moons inside our sun-powered framework may give experiences into how life might adapt to distinctive situations, advertising clues for the look for extraterrestrial life. As we continue to investigate and get at our universe, the thought that we dwell in a supervoid seems reshape our understanding of enormous structures and the dispersion of matter. It challenges the routine models of cosmology, empowers us to rethink the elemental strengths governing the universe. Whereas it could seem overwhelming to think of ourselves as confined in a vast cosmic void, it too opens up new avenues of investigation and revelation. The concept of the neighborhood gap and the plausibility of a supervoid encompassing us highlight the complexity and puzzle of the universe. As our innovation progresses and our observational capabilities improve, we may reveal more almost these tremendous purge spaces and their suggestions for the broader universe. Whether or not we are truly alone in our cosmic neighborhood, the quest for knowledge and the rummage around for life proceed to drive our exploration of the universe. Normal matter density. Typically, voids have breadths extending from 30 to 300 million light-years. On the off chance that you were within the center of one, it would show up as unceasing haziness, with the closest stars nearly imperceptible. A few voids, called supervoids, are especially large. The biggest known supervoid, suitably named giant void, is 1.5 billion light-years absent with a breadth of 1 to 1.3 billion light-years, and contains 17 partition system clusters inside its endless scope. Be that as it may, an indeed bigger vacancy might exist. The cold spot. This unusually large and chilly region of the universe was observed through microwaves and proposed in 2015 to be a supervoid, conceivably the biggest ever, called the extraordinary void, with an emptiness of approximately 1.8 billion light-years in diameter. This disclosure of possibly dwelling in a supervoid altogether challenges the standard show of cosmology. The standard show of cosmology, the standard show backed by Einstein's speculations, proposes that such a critical underdensity shouldn't exist. This peculiarity, alluded to as the neighborhood gap, has driven researchers to reevaluate the behavior of gravity and the dissemination of matter within the universe. If we in fact possess a supervoid, it might explain why our galaxy is encompassed by generally few other systems. This may moreover give clues to the Fermi conundrum, proposing that intelligent life may be scarce in our prompt infinite neighborhood, with aware creatures conceivably existing past our supervoid. In spite of our apparently disconnected position within the universe, the hunt for life proceeds inside our possessed sun-based framework. Venus, in spite of the fact that harmful nowadays, might have once facilitated life when it had more Earth. Like conditions. Mars, presently a cold leave, is accepted to have had streams and lakes in the past, possibly supporting old life and clearing out potential fossils and surviving underground organisms. The moons of the gas mammoths Jupiter and Saturn also display interesting conceivable outcomes. Europa's subsurface ocean, Enceladus's water tufts, and Titan's hydrocarbon lakes all imply situations where life seem potentially exist, yet with diverse biochemistries from those on soil. The hunt for life amplifies past our sun-oriented framework to the broader universe, with gauges recommending that the perceptible universe might host around 5.3 trillion tenable worlds. One promising candidate is Kepler, 186, an Earth-like planet orbiting a red dwarf star around 490 light-years absent. Whereas this separate may appear endless, it is relatively close compared to the enormous scales of supervoids. Even if we are in a supervoid, the nearness of various universes and planets around us offers trust. In the event that humankind finds a way to travel through the universe, taking off the neighborhood hole and investigating these far-off universes might one day become a reality. The quest for information and the rummage around for life proceed to drive our investigation of the universe, despite the challenges postured by our possibly separated position within the infinite scene. Normal matter thickness. Ordinarily, voids have diameters ranging from 30 to 300 million light-years. In the event that you were within the center of one, it would appear as interminable obscurity, with the closest stars nearly imperceptible. A few voids, called supervoids, are especially huge. The biggest known supervoid, aptly named Monster Void, is 1.5 billion light-years, absent with a breadth of 1 to 1.3 billion light-years, and contains 17 isolated galaxy clusters inside its tremendous region. In any case, an indeed bigger vacancy might exist. The Coombe Cold Spot. This unusually large and chilly area of the universe was watched through microwaves and proposed in 2015 to be a supervoid, conceivably the biggest ever, called the Incredible Void, with a vacancy of about 1.8 billion light-years in diameter. This discovery of potentially dwelling in a supervoid essentially challenges the standard show of cosmology. The standard demonstrate bolstered by Einstein's speculations recommends that such a critical underdensity shouldn't exist. This irregularity, alluded to as the local hole, has led scientists to rethink the behavior of gravity and the conveyance of matter within the universe. In the event that we in fact possess a supervoid, it might explain why our system is encompassed by generally few other systems. This might moreover give clues to the Fermi conundrum, proposing that intelligent life may be rare in our quick, enormous neighborhood, with conscious creatures conceivably existing past our supervoid. In spite of our seemingly isolated position within the cosmos, the seek for life continues within our possessed sun-powered framework. Venus, in spite of the fact that harmful nowadays, might have once facilitated life when it had more Earth. Like conditions, damages, now a cold leave, is accepted to have had waterways and lakes within the past, possibly supporting old life and taking off potential fossils and surviving underground microbes. The moons of the gas giants Jupiter and Saturn, moreover, display captivating conceivable outcomes. Europa's subsurface sea, Enceladus's water crest, and Titan's hydrocarbon lakes all imply at environments where life could potentially exist, though with diverse biochemistries from those on soil. The seek for life amplifies past our sun-based framework to the broader universe, with gauges proposing that the observable universe might have around 5.3 trillion habitable worlds. One promising candidate is Kepler, 186, an Earth-like planet orbiting a red overshadow star approximately 490 light-years away.